All right, welcome to Quarantined Math, Day 2 for math analysis. What we're going to do today is we are going to kind of finish up the review prerequisite kind of stuff with functions before we get into derivatives. By the way, our special guest star, Majin the Ferret. So we're going to kind of complete the 4 problems that we saw at the end of the video yesterday, meaning we're going to go ahead and solve those, see what we would get if we actually went ahead and substituted in those like binomials or expressions that we were putting in the functions. On Monday, we're really going to tackle what is a derivative, what does it mean, what are we even talking about with it. We'll be getting out of this prerequisite stuff and we'll be getting slowly starting to get into the packet at that point. But today, we're going to finish our prerequisite functions review. All right, so we are going to work through these problems. These are the same 4 from yesterday that we were working on by taking the function, the name of it, so being able to identify what equation we're using, and then substituting in whatever was in these parentheses for our value of x. At this point, we want to actually finish simplifying the function, meaning just kind of put it in simplest form, combine like terms if possible, that kind of stuff. But the biggest thing that we see, and kind of the most important thing I want us to talk about, because it's been quite some time for most of us probably, is simplifying things like this. 9 times 2x plus 1 squared plus 2. You know, a problem like this very first one. Whenever we look at something like this, we have a binomial squared. And I think the natural reaction for most people whenever they look at this is to square the 2x and get 4x squared, and then square the 1 and still get 1. But that's not actually how this is going to work, right? Because whenever you square a binomial, we actually have a very important process of what we have to do there, and that is the process of foiling, or fueling, loifing, however you want to do it. So we're actually going to go through that process, and then we're going to do everything else that this kind of asks us to simplify it in terms of order of operations. We do want to keep in mind order of operations, because whenever we look at this, we have to ask ourselves, do we square the binomial first, or do we multiply it by 9 and distribute that in first? Well, order of operations, PEMDAS, as most of us think about it, or GERMDAS, as I am personally more of a fan of, tells us that we need to deal with exponents prior to dealing with multiplication. So we're going to go ahead and FOIL this. So I'm going to do that. I know we all know how to FOIL in terms of we've done it before and pretty extensively at many points, but it may have been like a year, so there's no harm in talking about it, reviewing it. So FOILing is first, outside, inside, last. We're going to multiply our first terms, 2x and 2x. Those multiply to become 4x squared. We're going to multiply our outside terms, the 2 farthest away terms, 2x and 1, that makes 2x. Inside our 2 interior terms, the 2 closest together, 1 and 2x to make 2x. And then last, the 2 final terms of each binomial, 1 and 1, which makes 1. We're then able to combine any like terms that we have in this. You will nearly always, and especially if you're squaring a term, so you're FOILing 2 identical binomials, you will 100% always have these 2 middle terms that are the same and able to be combined. So in this case, 2x and 2x are able to combine to make 4x, right? So we have 4x squared plus 4x plus 1. And that's what we get whenever we FOIL this right here. Now let's not forget the rest of the stuff in this function. We have the 9 outside of it. That's going to remain right here outside of what we got after FOILing. And then this plus 2 at the end. Now that we've dealt with our exponents, or dealt with FOILing, order of operations tells us we can move on to multiplication and division, and then finally, after that, addition and subtraction. So we have this 9 multiplying. Since it's outside the parentheses, it is going to distribute into all 4 of these terms. So all 3 of these terms. 9 times 4x squared is going to give us 36x squared. 9 times 4x will give us 36x. And 9 times 1 will give us 9. And then we still have this plus 2 hanging out at the end. So we've dealt with all of our multiplication. We don't have any division to deal with. So we can take that final step and deal with addition and subtraction. We see we have some addition that can happen in terms of combining like terms. We have a 9 and a 2 that both are constants or whole numbers or don't have variables. So they can combine and make our final answer to this equation be 36x squared plus 36x plus 11. And that is what we would get after simplifying this function, after doing everything we need to do, after substituting in what our function told us to. So that is the final answer to this question, g of 2x plus 1. I'm going to go ahead and work through these others a little bit quicker since we've already talked about it, but we're going to work through these as well. If you want to pause the video, try to work through them yourself, and then check your work, you can, or you can just follow along, kind of however you want to do this here. So x plus 2 squared is going to mean we're looking at x plus 2 times x plus 2. These will FOIL. We get x squared plus 2x plus 2x plus 4, or after we combine our like terms, we get x squared plus 4x plus 4. Now that takes the place, or is the fully simplified version of x plus 2 squared right there. So we are still going to have plus an x plus 2 at the end of it right here. We'll be able at this point to combine our like terms. X squared doesn't have anything to combine with, so it stays the same. We have a 4x and an x. Those two will combine to be 5x. And we have a 4 and a 2 that are going to combine to become 6. And this would be our final answer to our fully simplified function. These last two, 3 and 4, are actually a little bit simpler, a little more straightforward, because we don't have to worry about any squared variables. So these are going to be just a couple of steps. This 5 multiplying this binomial is able to distribute in. 5 times x is 5x. 5 times negative 9 is negative 45. And then we have a plus 9 at the end. We have two terms that can combine, and we get 5x minus 36. That one's already done. Finally, this one is actually the simplest of them all because it doesn't even have any multiplication happening. We're literally just looking at negative 3 plus 2x minus 5. We have some combining of like terms that can occur, negative 3 and negative 5, and ultimately we end up with 2x minus 8, and we're done. One thing I do want to have everyone keep in mind is the quote-unquote proper way to write these numbers mathematically, and that is with the highest exponent variable first. So whenever I was writing this, I think some of us may have looked at this and said negative 3, negative 5, that's negative 8, so negative 8 plus 2x. But even though that is the exact same thing as 2x minus 8, what we want to do is write those variables beforehand. It's not going to be a huge deal in derivatives, but it is going to be coming up a little bit, and that we want to make sure that we are careful with the order of which we write these in. So all in all, that's what I was wanting to do today, just finish out simplifying these composition functions and reminding us how this kind of stuff works. Monday, we'll have a video explaining what derivatives are. So it's going to be very much just a video about what are they, what do they mean, what are we even talking about whenever we say the word derivatives. It's kind of going to be a new idea in mathematics for most of us. But I personally find it pretty interesting. I'm looking forward to it. So if you have any questions on this, let me know. Otherwise, we will see you guys Monday.